Humans have the incredible ability to build vast repertories of skills. What's perhaps even more striking about it is our ability to set and pursue our own goals. My collaborators and I have been arguing that goals are central to human learning and decision-making. So to me, a central question in cognitive science is, how do people decide which goals to pursue? To start tackling this question, we developed a novel experimental paradigm in which goals, instead of being given to participants, act as the dependent variable. So imagine you're an apprentice alchemist, and in front of you is a dashboard that shows all the different potions you could try and create. How do you decide which ones to try and make? We developed some hypotheses based on previous work, which suggested that performance and learning progress are very important variables in driving human goal selection. Learning progress is particularly interesting because endowing artificial agents with a sensitivity to it enables them to learn autonomously and efficiently. In both human and computer science applications, learning progress usually is seen as a derivative of performance, so how much performance changes over time. But humans can perceive learning progress even without observing external changes in their performance, and we call this latent learning progress. To show you what I mean, let's go through an example from our task. So imagine on the first trial, you select this purple potion as your goal. You're given 4 different ingredients that you need to try and combine to make the target potion. You try by putting together ingredients in a certain combination, but you don't succeed. On the second trial, perhaps you try the same goal again, but try a new combination. And again, without success. You try this again, and again, until you finally find the correct solution. It's only at this point that the standard measure of learning progress kicks in, because that's the first time you observe a change in your performance. But because you know the space of possibilities is constrained to the different combinations of ingredients you can put together, you're actually making progress every single time you try a new combination just by going through a process of elimination. So this is what we call latent learning progress, and here we're interested in whether latent learning progress, or LLP, drives human goal selection. To validate our new experimental paradigm, we first looked at some general patterns in participants' behavior as a whole. When we looked at performance, we noticed that 2 aspects of the goal affected participants' ability to find the correct solution. The first one was whether goals could be achieved by putting together 2 or 4 ingredients. And we found that people were better at learning solutions that required only 2 ingredients compared to 4. The second aspect was hierarchy. So there were some potions that, if you learned a solution to them, it was easier to learn the solution to other potions. And this was only true for a subset of them. And we found that people were better at learning goals with hierarchical dependencies with others. When we looked at goal selection patterns, we found the opposite effects, such that people focused on goals that were harder to achieve and that didn't have hierarchical relationships with others. We were interested in whether latent learning progress could help us explain these patterns, and to do that, we turned to computational modeling. So we built sequential models of participants' goal selection by putting into them different variables like performance, different types of learning progress, and hierarchy. What you're seeing here is a responsibility plot, which captures how well each model represents the participant's behavior. And as you can see, models with latent learning progress, or LLP, do the best job. So in sum, we found some evidence that latent learning progress, a variable not previously considered in computer or human studies of goal selection, drives goal selection in our participants, at least in this task. We also found some initial evidence that hierarchy plays a role, although it's still unclear whether it does so directly or by affecting learning, so indirectly. I also didn't have time to include it here, but we found a lot of richness in individual participants' behavior, and we hope to capture that richness in future modeling endeavors. So by introducing latent learning progress, we hope to better explain participants and, in general, human goal selection, and perhaps foster the development of machines that, like humans, set and pursue their own goals. Thank you.